the things that I talk about are only from my experience. And I hope that I can share concepts and ideas that you can translate to your specific conditions. So I'm going to go ahead and share my screen. As we talk about turf grass management in a changing climate, with this great picture here of a golf event that's been put on hold because of weather conditions. So I'm from Wisconsin in the US, which is circled there in yellow. We have about 5 million people in our state and quite a few golf courses, so 500 golf courses. The largest city next to us is Chicago. So if you've heard of Chicago, Chicago's down here in Illinois, and I live right about there in Madison. So the reason Wisconsin has so many golf courses is our third largest city in the United States is just south of our border, and they like to come up and play golf in Wisconsin. It's not really pleasant here. It's I just looked at the thermometer. It's -11 Celsius right now. Ice fishing is a really popular sport here, which sort of tells you how cold it can get. And we're famous for beer and cheese and cows. We have 5 million people in the state, but about 3.5 million cows. So it's a pretty rural place. We're very famous for golf courses. Whistling Straits is one of our best known golf courses. This is Lake Michigan. It looks like an ocean when you're next to it and the waves are up. We were supposed to have the 2020 Ryder Cup, or we will have the 2020 Ryder Cup. That'll be in 2021. And this golf course has hosted several PGA championships. And then in 2017, we had a golf course that hosted the US Open, which was a first for our state. And so we're really proud to do that. So a lot of great golf courses in Wisconsin, and most of them are public, which is sort of unique for American golf. So today, the overall theme is climate change. And of course, climate change is a global phenomenon. And I just show this as an example of how the climate is changing where I live. And these are hardiness zones. So we have a USDA system that ranks plants based on, how cold tolerant they are. And this is a map of the hardiness zones in 1990 versus 2012. And the colors are a little bit unfortunate because red and orange are actually more cold tolerant, but you can see the red and oranges are leaving and the greens
I'm gonna stop you for one moment, Doug. Iedereen die aan het kijken is, als je per ongeluk Doug heel groot ziet en zijn presentatie heel klein, dat betekent dat je rechtsboven op het monitorlogotje moet drukken, dan switch je dat. Dan is Doug in het klein en dan is de presentatie in het groot. Ik weet niet of andere mensen dat ook ondervinden, maar dan weten jullie dat. Thank you, Doug.
But globally, so the way that I communicate how climate change is happening in Wisconsin is that the winters are getting, the cold temperatures are getting warmer. So we're not necessarily seeing warmer days, as in the high temperatures are changing. We're actually just seeing less cold nights and less cold winters. And I think that trend is similar globally, but again, all climate change is local. Globally, though, overall, the mean annual temperature is expected to increase by 2 degrees Celsius, and precipitation is expected to vary depending on where you live, from 20% less to 20% more. But the extreme precipitation events are expected to increase by 20%. So, and I grabbed this this capture on the right here of observed climate change in Europe, talking about similar trends with precipitation and droughts and temperature. So I like to show this pattern because I think it really drives home the unequal distribution of where the warming is occurring. And so in the Arctic in the northern part of our globe is where the greatest temperature changes are expected to occur and are occurring. But so there's some interesting things that that you don't often hear about in the news, and that is that the increased carbon CO2. So right now our CO2 concentration is about 410 parts per million, and it's expected to increase to about 500 parts per million in the next several decades. And that carbon dioxide is what plants use to make sugar. And so researchers have been studying how increasing CO2 will affect plants. And in surprisingly, well, I guess maybe not surprisingly, but it helps plants. The more CO2 that you have, regardless of the temperature and the climate change effects, will make plants more efficient. And so these studies have shown that plants can grow better with less water, but maybe reduced protein content, which is really important for animal feed, but probably less important for turfgrass management. So far, we've observed some of these effects. So this is the vegetative cover of arid land of the globe and how it's changing. And so you can see in some of these dry areas of the globe have the darkest blue. That the vegetative cover there is increasing because of the increased CO2, and increased CO2 makes plants more water use efficient. So that's one of the possibly positive changes of increased CO2. And then we have a map here of crop growth. So, and this is specific to agriculture, not turfgrass management, but you can see that unsurprisingly, we're expected to see increases in crop production and growth in the northern latitudes, and then strongly reduced crop productivity in the mid latitudes and near the equator. So in Wisconsin, where I live, there are people that think climate change is great because farming is important and we're going to have more crop growth, which is a really sad view. We're a global society these days, and we need to think about the net, just not the local effects. But the reason I bring this up is that, and of course, Northern Europe is expected to be similar with seeing increased crop productivity, is that this is what I want to focus on for the talk, is that you're likely going to see gradual changes in the amount of grass that you grow and the organic matter that you produce in your soils. And so I want to discuss some strategies for dealing with those changes as they're occurring. So we know that grass produces a lot of roots. This is an upside down stand of grass that was grown in the greenhouse in a hydroponic solution. So here's the surface. You can see all those roots that plant produces, and that translates to organic matter. So your organic matter here is accumulating every year in this sand root zone. And of course, we spend a great deal of time and money managing that organic matter by aerification and top dressing. But if climate is increasing the growth of the plants, you can expect changes in the way that organic matter accumulates. And so your traditional top dressing and aeration plan may stop working, or you might see more carbon accumulation. So nitrogen management is growth management. And our job, if you think about our job as turfgrass managers, is to find the ideal growth rate. If you're a farmer, your job is to maximize your productivity. But if you maximize your productivity in a turf situation, you're going to lose your job. But what you need to do is find the optimal growth rate, a nice balance of traffic tolerance, but also slow enough growth for good surface characteristics. So nitrogen is usually the thing that drives our growth. And so you need to understand how much grass you're growing. So if I'm telling you that the climate and the weather is changing the way that your grass is growing, it's good to measure that. So I was thinking about this last night, and without careful measurements, we wouldn't know that the climate's changing. Without the observatory on the top of Mauna Loa in Hawaii that made the first observations that our CO2 levels are increasing, would never, without that measurement, it wouldn't have led scientists to hypothesize and think, well, I wonder if temperatures are changing or how other things are changing. Everything we know about climate change has been observations made by very careful, precise measurements, because the weather is too variable to notice changes over time. And when somebody says, well, when I was younger, I remember it being much colder, you don't really know if that's just a trick of the mind or experience until you make careful measurements to confirm those observations. So what I'm going to try to convince you to do is measure your growth. Make a careful measurement of your growth, and that's going to help you make better management decisions. So superintendents have started measuring clipping volume, at least in the U.S., and I'm sure in other parts of the world as well. Here's some comments from Twitter of people talking about measuring clipping volume as being a really important technique that they use to make management decisions. So if you're not measuring clippings, I think you should start measuring your clipping volume. Again, these changes in growth are gradual and slow, and by understanding how your growth is progressing, you'll be able to make better management decisions. So there is a lot of resistance to people measuring their clippings. And so this slide is from a golf course superintendent in Minnesota, Chris Trittabaugh. Minnesota is a state right next to me. And he hosted the Ryder Cup, let's see, that would have been 2016 at his golf course. And so he relies on clipping volume collection. And he put together this slide for how he responds to people who say why they don't like to do it. So probably the number one thing he get is, I don't have a bucket, which is the weakest excuse. Well, you can get a bucket that has graduations on it almost anywhere, maybe Amazon. The next one is it takes too long, and it doesn't. This is a really short process. So after you're done mowing, it takes one extra step. You dump your clippings into a bucket. And it might take an extra minute per green. And of course, we know it takes maybe a half an hour to mow a green. So it's not increasing the time very much at all. It's not accurate enough, but that doesn't make any sense because the thing that you're doing now is nothing. And so even if it's not perfectly accurate, it's a measurement that's more careful than what you're doing now. And then how do you keep track of the data is a valid concern. Chris uses a Greenkeeper app. I have a spreadsheet that I'll share with you and show you where you can download. But the data management is not that difficult if you let's say you're measuring 18 or 19 greens. You need to enter 18 or 19 numbers into a computer each time that you mow, and then it shows those programs automatically graph up the results. And then another big one that I hear and Chris hears is that I can tell how fast my grass is growing. So some people get offended when I say you should pay attention to your growth, because they say, of course, that's what I do. I look in the baskets, I look in the back of the utility vehicles, and I know how fast the grass is growing. I don't need a bucket to tell me that, but I'm going to tell you that you cannot, you don't know how well your grass is growing until you measure it like this. It helps with mower setup too. So if you have a triplex mower and you just measure the clippings that are coming from each of the 3 reels, you might notice that one reel is getting 20 or 30% more grass than the other 2 reels. And you would never know that by simply looking in the baskets. And so that doing something like this can help you improve your mowing setup, which of course is hugely important. So my point here is that humans, we are not great observers, and having data helps. Like I said, I don't think we would be talking about climate change at all if we were completely oblivious to the measurements that scientists are making. For example, this is a classic study where a white wine was dyed red and given to groups of wine drinkers. So these are both the same wines. The only difference is this one has a dye, colorless, or I'm sorry, odorless dye, tasteless and odorless dye. And they asked these wine drinkers to describe the wine. And so you know that certain words are associated with white wine and red wine. You know, red wines are talked about as berries and tobacco and leather, and white wines are described as honey and floral and citrus. And so these are identical wines, but when the wine was white colored, every dot is a white wine descriptor word. So when the wine was white, these are the words that people used, white wine words. And when the wine was dyed red, the exact same white wine, they used red wine words. So these are wine drinkers that probably wouldn't believe you if you told them that white wines and red wines are hard to tell the difference between. But when you just color them, they describe them as whatever color the wine is. Here's another one. If that didn't convince you, this gray bar in the middle is actually the same color all the way through. But every time I look at this, it doesn't seem right. The bar, this part looks dark and this part looks white, and I'm sure it's the same for you. But as I take away the surroundings, you'll see that that is indeed the same gray color. Right, so we are easily fooled by what we expect, what our expectations are. And you're the same when you're mowing your grass. You have an expectation for how fast the grass is growing, and your expectation colors your response. If you throw the grass in a bucket, that effect goes away. This is another one of my favorites. It's a cartoon. These doctors are in surgery and they say, we'll just mill around till he's asleep and then send him back up. This operation is actually for placebo effect. It's not that funny. It's not a very funny comic, but the best part of it is it's basically true. So this is a summary of this study in the New York Times. They did this on 180 patients, and the 180 patients were broken into 3 groups. One group got the standard procedure. The second group had an experimental procedure that they wanted to test. And the third group had a sham surgery. They had an incision and a procedure was faked. So they didn't know that they actually had nothing done. So they got a scar and nothing was done. The results were stunning. Those who had the actual procedures did no better than those who had the sham surgery. They all improved the same amount. So if they just cut your knee open and send you back up, as is suggested in this comic, you're likely to get better just as if you had the surgery. So that's crazy, right? But it just goes to show you how powerful this placebo effect of what your expectations are. So maybe you've seen a change in this already with soil moisture. When I first started in 2006 here at the University of Wisconsin, very few superintendents were measuring soil moisture with meters. They said, I can tell just by looking, I can feel the soil. But now as more and more people use these sensors, they are making observations that they would never had made before and are dramatically improving the moisture management of their golf course. And so now very few people say, I don't need a moisture probe, I can tell just by feeling. So I can think of very few examples when having more data doesn't make you better at making decisions. So the question that we don't know right now that I think is keeping people away from measuring clippings is, if I can go back for a second, we sort of know the optimum soil moisture levels. So for sand greens in Wisconsin, most people want to be about 18 or 20% moisture. But we don't really have a good feel for what the optimum growth rate is yet, but it's starting to develop. And there might be different growth rates for greens. There might be different growth rates for tees or fairways or different species of grass. I know, that you have brown top and fescues and a lot of different grasses that I'm not growing. So we need to figure out what the optimum growth rates are. But once we have those, we can benchmark and we can strive to hit those targets. So for example, in creeping bentgrass, my years of my research have determined that about 1.25 grams of grass per square meter per day is about optimum. So this is a target that works at my research facility that I like to hit. And so let me just show you why that's important. Is we did a study where we had different levels of traffic, foot traffic, and different levels of nitrogen. And if we wanted to hit, this is my optimum, this red line right here. That's my optimum growth rate. If I want to hit that target under high traffic, I need, and I'm sorry, I forgot to convert this slide, but that's that's about 40 kilograms per hectare per month to hit that target. That's a lot of nitrogen. Under low traffic, I could almost hit that target here with 20 kilograms per hectare. And under no traffic, on the right, I hit that target with no nitrogen. But I don't know about you, in Wisconsin, people apply fertilizer every month or every other week, and they're not thinking about if they need to or not based on how fast their grass is growing. If your grass is growing really slow, you should probably increase your nitrogen rate. If your grass is growing medium, regular fertilizer application, and then if your grass is growing really fast, you don't need to apply any. And so having an estimate of the clipping production can guide your decision making on fertilization. So the nitrogen cycle is really complicated, and we talk about this in my soil science classes, but you can simplify it greatly for turf grass management systems. The only thing that really matters for nitrogen removal is crop harvest, especially when you're removing clippings on greens. This is the way nitrogen leaves your system. The only way nitrogen enters your system is through fertilization, for the most part. So these other processes that I'm crossing out aren't big components of a nitrogen system. We don't have plant residues, manures, atmospheric fixation, biological fixation. So when you have one input and one loss, and you can measure your input, which is how much you're fertilizing. If you can measure your loss, then you know whether or not your organic matter is going to change or not. So if these two are in balance, if crop harvest is in balance with fertilization, then your organic matter level will stay the same. But if crop harvest is greater than fertilization, organic matter will decrease. And if it's the opposite, where your fertilization is greater than your harvest, organic matter will increase. So we call that the checkbook method, and checkbooks are kind of going out of style these days, but your nitrogen additions should probably be equal to your nitrogen removal to keep things in balance. This is a spreadsheet that I talked about that's available. You can download this at www.turf.wisc, for Wisconsin.edu. And it's an Excel spreadsheet, which when you enter your clippings, will start to track the amount of nitrogen removed. So this is in pounds per 1,000 square feet, but this golf course, which tracked their clippings all year, can see how much nitrogen they're removing. And by the end of the season, they removed 100 kilograms per hectare. So that would be a good guide for that golf course to think about if their nitrogen application rate is matching their removal rate. These are data from golf courses in around where I live. 10 golf courses were collecting clippings. Their nitrogen applied was 75 kilograms per hectare, and their nitrogen removed was 55 kilograms per hectare. So that's pretty close, right? It's maybe they're applying a little bit more than is being removed, which I think is probably normal, but they're not dramatically out of balance. So like I said, it's not that I'm telling you you're doing everything wrong, but having data is going to make you a better manager, and it's going to reinforce the good decisions that you're making and maybe show you some new tricks. There's some emerging guidelines. I have this in really fine print because I don't want to overemphasize it, that these guidelines are coming from the part of the world that I live in, and in your region, they may not be good guidelines. But where I live, if you're growing about 10 milliliters of grass per square meter, That's tournament conditions, but probably not sustainable for the year. In that case, you're removing more grass than nitrogen than you're adding. A good daily average would be double that, about 20 milliliters per square meter. And if you get 40 milliliters per square meter, we consider that excessive. So those emerging guidelines are from people making observations about the quality of their grass and seeing what's in their clipping collection buckets. So what I'll say here is that you should be testing your greens, your soil testing program, primarily for organic matter. You know, I'm in the Department of Soil Science, and I spend a lot of time looking at soil test reports. And people love to look at their nutrient levels and think about their fertilizer that they need to add. But I think probably the most critical thing is to look at your organic matter levels, especially in the context of climate change, where we're maybe growing more or less grass. The seasons are longer. We're fertilizing grass later than we have or earlier than we have before. And so all that has implications for organic matter.
We're about 30 minutes out, so you know.
Sounds great. Thank you. So I think you should focus on your organic matter levels. So when I said we wouldn't know climate change wasn't happening without measurements of the CO2 in the atmosphere and the careful measurements of the ocean temperatures and the land temperatures, this is what you're doing. You should be looking at how your organic matter levels are changing over time, and they're likely changing very slowly, but in a way that matters. So general principles for testing for organic matter. If we did a soil nutrient test, we may test the root zone, which might be about 7 centimeters, maybe 10 centimeters. But with organic matter, we're actually more concerned with the top 2 centimeters or so, and then maybe the next 2 and the increments down. So you need to know how these samples were collected and where they came from, and then how they were analyzed. And probably a bit beyond the scope of this presentation, but in short, collecting soil samples and sending them in for organic matter analysis, is probably a practice that you should be thinking about, as well as collecting your clippings and tracking your growth. And so the point is not to hit targets of organic matter, but to track your changes. Is your organic matter increasing or is it decreasing? That's something that you'd want to know. If it is increasing, that means that you're probably putting down more nitrogen or not top dressing or aerating aggressively enough. If it's decreasing, it means that you're probably not fertilizing as much as you should. So probably the most prominent method that I hear about these days is Micah Woods of the Asian Turfgrass Center's OM 246, organic matter 246, and that's the depth increments he recommends. So sample at 0 to 2, 2 to 4, and 4 to 6 centimeters. Don't remove the plants, so send the plants into the lab. And in doing that in his region of the world, he's found an average of 7.3% organic matter in the 0 to 2 centimeter depth range. He recommends doing at least 3 greens every year with about 5 sub-samples per green. So that means you take 5 cores on a green and mix them together and send that off as one sample. And then Micah also points out that the goal is to track changes over time, not to hit a target. He's not saying 7.3 is optimum or that's too high, just saying track your changes and pay attention to which direction that organic matter is headed. Here in Nebraska, which is about in the geographic center of the United States, Dr. Raku Swa has been testing organic matter in turf areas for years, if not decades. He recommends sampling from 0 to 8 centimeters, so a much deeper sample, and he recommends removing the grass, the verdure, and in doing that, he finds an average of 3.1% organic matter. And I think this picture on the right shows why I think that this method is probably not the best. Is that your golf ball is about 4 centimeters in diameter. And you can see that this sample then, if we were to sample that at 8 centimeters, we would have a region of very high organic matter and a region of low organic matter. So if that's changing over time, we don't know if the depth of organic matter is getting greater, or if maybe we're increasing the surface organic matter. So by taking samples and cutting them up into smaller increments, say 2-centimeter increments, you can get a clearer picture of where the organic matter is in your soil, rather than taking an 8-centimeter or 10-centimeter sample. Another researcher has sampled from 0 to 10 centimeters in 2.5 centimeter increments. So there's no magic number. And in fact, this picture I showed you earlier was from Dr. Doug Lindy, who sampled 155 different putting greens in the East Coast of the United States. And he found 76% had less than 3% organic matter in the top 2 centimeters. So that's about half of what Michael Woods found. So again, we don't know what the targets are for different regions or different places, just like with clippings, but you can probably find that the changes from year to year are what matter more than the actual numbers. Dr. Lindy has a good advice here. He recommends testing your best and your worst greens every year. I think that makes a lot of sense. So you should probably be testing, I'll say this again, your organic matter first, and looking at nutrient levels as a secondary point of interest. And then the questions we're going to ask related to our management here is, why are we doing all the same practices, top dressing, aeration, if we have differences in putting greens? So these are samples from a study that was collected in the top 2.5 centimeters. And this is about 5% right here. And then this is about, what, 2.5%. So let's say your best performing green had 2.5% organic matter and your worst had 5%. Why do we treat those the same? Shouldn't our goal be to get them to be more consistent? So can these numbers help you change your operations? I hope so. And an adage that I really like to repeat here is, you can't manage what you don't measure. So that goes for clippings. When we manage our nitrogen, if we're not measuring our growth, it's hard to manage nitrogen. Similarly with our soil practices, it's hard to manage or know that you're making the right decision if we're not measuring organic matter carefully. Okay, so that's kind of my my story for how I view turf management in a changing climate, is make careful measurements. That's why we know climate change is happening, and to be a better turfgrass manager, you want to make careful measurements as things change slowly over time, and hopefully lead you to making more effective decisions. Okay, I'm now going to switch to diseases a bit here and share some experience that we've had with nutrients and diseases. So as your climate changes, I'd expect that snow mold, microdochium patch becomes more of a challenge, or a challenge for longer periods of the year. Also, dollar spot is another, that's my main disease, and I think one that is going to increase in your world going forward. So with snow mold, one of the first observations here is that having low potassium minimizes snow mold. So these two plots received no potassium, and then these two plots received about 20 grams per square meter or 80 grams per square meter, and you can see that they're more affected by snow mold. Same plots here again, just at a different time in year, and you can see that the plots with no potassium recovered better than the plots with high potassium. This is for creeping bentgrass. Oops. Another, an opposite effect here was that having low potassium, so this is 1% potassium in the tissue, this is 2%, this is 3% potassium in the tissue, increases, so this is bad, anthracnose. So having low, and anthracnose is a common disease on annual bluegrass in the summer. And so these researchers at Rutgers found that the best way to minimize anthracnose is to have high levels of potassium. So nutrient management can absolutely affect your disease management. The good news on this is that these two diseases don't co-occur. Anthracnose happens in hot weather and snow mold happens in cold weather. And so you can modify your fertilization program to optimize the disease tolerance at those 2 points in the year. Here's some more data on pink snow mold from Cornell University, where they found the number of days it took to kill half of the grass was longer with low potassium grass. When the grass had high potassium, it took a shorter amount of time for that snow mold to kill the turf. And this was on annual bluegrass for this particular study. But on the other hand, and I don't think that this is going to be a concern for your region, but maybe, low temperature kill is greater on annual bluegrass that has low potassium. So now we have, it just keeps getting more and more complicated. We have annual bluegrass that's going to be more susceptible to winter kill if it has low potassium. And so here's another picture of that shows the dead annual bluegrass plots here because of low potassium. So the low temperature kill was, down here at 7 degrees Fahrenheit, which is really quite cold, right? I don't know what that is, minus 20, minus 15 Celsius. So that's another concern, is how nutrient levels may affect your winter tolerance. These are some pictures from my studies. This is low potassium, and then these plots are 1, 2, and 3 rates of potassium. So you can send 3 being the highest rate. So as we get to that highest rate, we see more and more microdocium patch. So again, just more evidence that low potassium discourages microdocium patch. Same plots, different year. These are both low K, and these are high K. And you can see the difference in microdocium patch pressure there. Same thing, this is low K, and this is high K. So clearly we see this again and again, that having low potassium discourages microdocium patch, but there's some negative consequences to having that, especially with annual bluegrass. Another picture here, different year, no potassium on those 2 plots, and then high potassium here. So there's just big differences. So you want to pay attention to your potassium as you worry about microdocium patch. In the summer, they look the same. So this hasn't had potassium in 7 years. Actually, now this is from 2016, so it's over a decade where we haven't put any potassium fertilizer on that plot, and it looks wonderful. Looks just as good as the one that gets about 5 kilograms per hectare every 14 days. 5 kilograms per hectare. So that's a normal amount of potassium. It's not even that high, but when we flip back to it, you can see that it gets snow mold at a much greater rate. Okay, switching over to dollar spot here, and this is where I'll stop, is that we've noted that nitrogen plays a big role in dollar spot, but the bad news is that you have to put down way too much nitrogen to get this effect.
We're about 45 minutes in.
Sounds good. I'll wrap it up here, Giannis. This is about 300 kilograms per hectare per year. Way too much nitrogen to get that decreased effect for dollar spot. We tested different rates, and this work, I should say, is a collaboration with my colleague Paul Koch, University of Wisconsin, a great expert on diseases and dollar spot and microdocium. If you're ever looking for a speaker to talk about that, Paul Koch is excellent. So we work together. I'm the nutrients person, he's the disease person, and we put down different rates of nitrogen, and we only really saw this one having a great effect, this 300 kilograms per hectare. So in Wisconsin, we usually don't exceed 100 kilograms per hectare. And so we had no effect, and that's per year. We had no effect at that rate. Here's just the data on here. You can see this is a non-treated control. This is our normal nitrogen rate. And so you had to go way up here to 300 kilograms per hectare to see that effect. The cool thing though is that Dr. Koch thinks that this is what's happening is the high nitrogen rate is actually changing the soil microbes. And so if that's really the case, that maybe we can change the soil microbes in a different way that can discourage dollar spot. So that's something that his lab is looking at right now. Of course, I know you all are aware of the effects of iron sulfate for disease management, and we've been studying that too. We find that the best rates are about 19 kilograms per hectare of iron sulfate heptahydrate every 7 days. And this is a plot here from 2018 on a bentgrass fairway that shows that we're able to keep dollar spot basically at bay. Same here, another year, 19 kilograms per hectare every 7 days. In Wisconsin, if we start spraying every 14 days, the effect goes away and dollar spot will come in. So we have to apply, this is the lowest rate we could get away with. And then this is the shortest interval that we could get away with to get effective control. But of course, the definition of effective is varies. And so I think this should be fine, right? So we have to talk about thresholding and picking levels that are reasonable, and we're not very good at that in the United States yet. We think that I say we loosely here that turf has to be 100% clean. But anyway, I think I'm almost on my last slide here, and then we can talk. We have a chat. But Pace Turf, really good information center, has noted that using high rates of iron sulfate, while it works to control dollar spot, and I apologize that you can't read this, in Canada, has increased take-all patch. And so I know take-all patch is another disease that you all deal with, and by applying lots of iron sulfate, these researchers and superintendents have made the observation that it makes take-all patch worse. And so I think nutrients have a big role to play in managing diseases and as they change, as our climate changes. But we need to continue supporting research and efforts to figure out all these crazy interactions. So in summary, we have a lot of complicated ways to influence disease. I think that if you take one thing away from this talk, though, I'd like you to consider collecting clippings and tracking your growth, and then tracking your organic matter levels. As the climate changes, we can expect things to change very slowly, almost imperceptibly, and having accurate data is going to help you react to those changes before you're able to detect it with your eyes or with your hands. So with that, I think I'll wrap it up. Again, thank you so much for the invitation to speak to you all. Again, wish we could do this in a different format. Hopefully someday soon in the future. So thank you, and I would be happy to answer any questions that may have come up.
This has been very awesome, Doc. Thank you already. Very practical, pretty much easy stuff to do for us all here. I think a lot of greenkeepers read about all these kind of things, but we're not yet implementing this through and through. But I think you broke it down very good, and it's very easy to implement for us. As I am talking right now, so I have two questions, so I just go ahead. My first question is, you talked about high traffic, low traffic. How do you decide what is high traffic and low traffic? Do you have a number for it? This much traffic on this much square meter a year?
Yeah, we did. There's been some researchers who looked at the number of steps that were taken around a golf hole within about maybe a 10 square meters within the hole, and so we sort of use that as the guideline. And our high traffic is came from a golf course in Wisconsin with high traffic, might have about 40,000 rounds per year. And so that was our target there. And then our low traffic was about 10,000 rounds per year, which would sort of be the country club that doesn't get a lot of play.
Okay. And my second and last question is, I saw the rates of nitrogen were effective against dollar spot, but you only treated it with urea. Do you think there's a difference in urea over, for instance, another form of nitrogen, or is it?
Yeah, so we actually tested that, and I didn't show the results because we found that it didn't matter. So we looked at ammonium sulfate, urea, calcium nitrate, and maybe another source in there as well, but they all had about the same impact.
Okay, awesome. You got any more questions, Martijn?
Yes, we have one from Chris van Ingelgam. Chris, maybe you can ask the question to Doug. Unmute.
Yeah, here we are. Hi, Doc. It's Chris here from Belgium, not from the, but that doesn't matter. I was wondering if you have any results applying iron sulfate in accordance to the microdocium patch. Do you have any results of that? Because you talked only about the control of dollar spot.
Yeah, that's a great question, Chris. And the reason I don't have results from that is because our climate is so different where we don't have, our microdocium shows up under snow. And so we can't go out and apply iron sulfate. But in different parts of North America, they do have that where they, like, I think University of Oregon or Oregon State University has looked at that, and they find that you can get microdocium control with iron sulfate, but the rates were really quite high, like 50 kilograms per hectare. And like I said, we think those rates are too high, and we would like to see people experiment with lower rates, 19 kilograms per hectare or lower. But I think you could probably get good control at approximately the same rate, but I don't have the data.
Okay, thank you.
We have another question from Lutz Mangelaar-Meertens. Lutz, maybe you want to ask the question. Tell the question.
Yes, I would like to know the effect of iron sulfate on the microbial life. You use quite high iron or sulfate of iron, and what is the effect?
Yeah, that's a good question. I think what happens with iron is that it'll precipitate out. So soils have a lot of iron in them naturally, a lot of iron oxides. And so I don't think that the iron is going to be a persistent toxin to microbial life in the soil. But I think when you apply it to a leaf surface at that high of a rate, it changes it makes the leaf surface inhospitable for the pathogens and for microbial life. So, I mean, it's a great question, because, you know, a lot of times when we think we're solving a problem, like, can we use iron sulfate to minimize our reliance on pesticides? And we find good results. And then years down the road, we find, oh, we made a huge mistake by using this particular product and this rate that we thought was solving a different problem. So I don't want to say that that I'm not concerned, but because the way iron sulfate behaves in soils, it oxidizes, and I think it won't, you know, it won't become a persistent toxin, but I don't know that for sure.
Thank you.
Once in a while, I speak to a head greenkeeper that's not so much a fan of the iron sulfate, but tend to use the iron gelate more. I think the sulfate piece is the thing you're aiming for, but do you have any knowledge about the iron gelate?
Yeah, we've studied the iron chelates, and they do make iron toxic. So they're the whole purpose of an iron chelate is to keep iron soluble and prevent it from oxidizing and becoming unavailable. And so the results are you can get disease control at lower rates, but it also increases the toxicity of the iron and the mobility of the iron. And so we've stayed away from the iron chelates for that reason.
We
I
have
saw-
one more question, Doug. That's from Golf Club de Hoge Klei. Maybe they can ask the question by themselves to you.
Willeke, of niet? Je
Staat
microfoon
geen-
staat uit.
Okay.
Yeah, I see it in the chat. So
Okay.
it is a concern. If you have poor drainage, adding sulfur is not a good strategy. And so because you can get black layer. So anytime you have wet conditions and a lot of sulfur, the microbes will take the energy out of the sulfate and form a reduced sulfur, which can be a problem. So I don't expect that it's going to be a problem everywhere, but in those poorly drained areas, absolutely putting a lot of sulfate, can be potassium sulfate, any form of sulfate down could encourage the formation of black layer. So you want to be careful with using iron in poorly drained areas for sure.
I myself always combine it with aeration. If I put lots of sulfate on it, I always combine with aeration the same week, just to be sure.
Yep. Yeah, would I advise flushing regularly? I wouldn't, because if it's poorly drained, you're adding that water that's going to lead to potential reduced conditions. So the goal is to get oxygen in. So I would not flush the iron down in a poorly drained area.
But if you flush, do you use calcium?
No, I mean, so calcium sulfate would be the most mobile form that's often recommended, and that's going to make black layer bad too. So
Okay.
if you have poorly drained areas, you don't want any sulfate going down. Of course, if it's well drained, it's not a problem at all.
Yeah. Another question. Perfect. Do we have any more questions coming in?
Nope.
No.
I think that was it.
If anybody has a question while I'm doing the how do you call it? The rounding up, you're still able to. Thank you, Doug, again. And as you said, it's awesome that you've been here on Zoom. But we hope to be welcoming you soon in the physical space in Holland over here. Should be a nice vacation for you because it's not minus here yet.
I would love to visit.
For everybody watching, we did some recording, so this Zoom will be available very soon. The 17th this week, we're gonna do sort of the same thing about the same topics and maybe a bit different topics also in Dutch. It's with Casper, Koert, and me. We're using the 1.5 meter regulations we're looking at them very closely. But we're still going ahead with it. So if the following days you have still any questions, you can ask them to us by then. Doug isn't there then, but we can do, I think, a good job with answering them also. Well, that's me. Thank you, Doug. It's been awesome. Martijn? Jij nog iets te zeggen?
Nee, dit was een mooie sessie, denk ik. En laten we er donderdagmiddag een vervolg aan gaan geven met de panelsessie die om 2 uur start. En inderdaad, mochten er nog vragen over zijn, dan horen we dat graag.
Thank you, everybody. Awesome.
Dan sluiten we hem bij deze. Dankjewel.
Bye bye.